Hey students, today we begin exercise 2.2 of inverse trigonometric function. But before we proceed to the exercise, let us see some properties of inverse trigonometric function and a few concepts related to the exercise. So let the journey begin. This is your math mentor and your friend Kaushalya Jogia. So moving to the property number 1, we have sine inverse of sine x is equal to x. Now students, it is very necessary that x lies in the principal value branch of all the 6 inverse trigonometric function. Only then this property is satisfied. Let us assume that x is 30 degrees for example. तो यहाँ पे हमको क्या मिल जाएगा, sin 30 मिलेगा ये ब्रैकेट में. ओके, सो sin 30 इज व्हाट, हाफ, एंड sin इनवर्स ऑफ हाफ मीन्स व्हाट, sin के कौन से एंगल का वैल्यू हाफ होता है. सो अगेन वी गेट 30 डिग्रीज. तो जहाँ से हमने x सब्स्टिट्यूट किया था वहीं पे वापस आ जाता है. तो इट्स लाइक sin इनवर्स एंड sin कैंसिल आउट ईच अदर, बट ऐसा किसी को बोलना नहीं है. यू कैन जस्ट रिमेंबर लाइक दिस. Likewise it is true for all the 6 inverse trigonometric function. Cos inverse of cos x is x, tan inverse of tan x is x, and so on. Okay students, I hope you have understood. Coming to the second property, which says that sin inverse of 1 upon x is cosec inverse of x. Now students, it is necessary that x lies in the domain of this cosec inverse x, sec inverse x, and cot inverse x. Only then this property is true. Let us assume the value of x is 2, which lies in the domain of cosec inverse x. So if x is 2, your LHS is going to give you sin inverse of 1 upon 2, which is 30 degrees. RHS में अगर आपने 2 पुट किया तो RHS का आंसर मिलेगा आपको cosec inverse of 2, which is again 30 degrees. Okay students, so you can say that sin inverse of 1 upon x is same as cosec inverse of x, and so on. Okay, likewise cos inverse is associated with sec inverse, tan inverse is associated with cot inverse. Okay students, coming to the third property, sin inverse of minus x is minus of sin inverse x. Again it is very necessary that x lies in the domain of all the 6 inverse trigonometric function. तो sin inverse of minus x माइनस साइन बाहर आ जाता है, tan inverse of minus x माइनस साइन बाहर आ जाता है. Likewise for cosec inverse, but the remaining 3 inverse trigonometric function cos inverse, sec inverse and cot inverse वो थोड़े नाटक वाले, वो थोड़े जिद्दी है. वो बोलेंगे कि नहीं हम लोग को कुछ ना कुछ अलग चाहिए. तो cos inverse of minus x students, it is pi minus cos inverse of x. Likewise for sec inverse of minus x, it is pi minus sec inverse of x, and for cot inverse of minus x, it is pi minus cot inverse of x. ओके स्टूडेंट्स, तो आपको ऐसे याद रखना है कि जो 3 जिद्दी इनवर्स ट्रिग्नोमेट्रिक फंक्शन है वो है cos इनवर्स, sec इनवर्स एंड cot इनवर्स. ओके स्टूडेंट, लेट्स मूव टू द फोर्थ प्रॉपर्टी. sin इनवर्स ऑफ x plus cos इनवर्स ऑफ x is pi by 2. Again it is very necessary that x lies in the domain of all the inverse trigonometric function. Let's take an example. Suppose हमने लिया x का वैल्यू हाफ. ओके, तो sin इनवर्स ऑफ हाफ आपको क्या देगा, 30 डिग्रीज देगा, प्लस cos इनवर्स ऑफ सेम वैल्यू यू आर पुटिंग, cos इनवर्स ऑफ हाफ आपको क्या मिलेगा, 60 डिग्रीज. तो व्हाट इज 30 plus 60? इट गिव्स यू 90 डिग्रीज, which is pi by 2. Okay, coming to property number 5, we have tan inverse x plus tan inverse y is tan inverse of x plus y upon 1 minus xy. Let us see how this is coming. We start with LHS. Let us say this is A and this is B. Okay, so your LHS is now A plus B. So we can say that tan inverse of x is A and tan inverse of y is B. तो अगर ये tan inverse right hand side पे जाता है तो it becomes tan. So you can say that x is equal to tan A and y is equal to tan B. Now students, so what do you observe? Your LHS is currently now A plus B. Okay, now RHS में जो tan inverse आपको दिख रहा है, if it comes on the left hand side, it is going to become tan function. So can we say that LHS is now tan of A plus B and RHS is simply this bracket x plus y upon 1 minus xy. So this formula you have studied in your 11th standard, tan of A plus B का बोलो क्या है formula? It is tan A plus tan B upon 1 minus tan A tan B. Okay students, now on resubstituting the value, we can say that tan A is what? X. तो हमको क्या मिलेगा? X plus y upon this becomes 1 minus xy. Now imagine students, you are taking this tan function again on the right hand side. So we are left with what? A plus b is equal to tan inverse of x plus y upon 1 minus xy. But what was your a term? Tan inverse x. And what is your b term? Tan inverse y. So that's how you get the formula. Okay students, let's move to property number 6. So आगे चलते हैं. Property number 6 says that 2 tan inverse of x is sin inverse of 2x upon 1 plus x square. Now imagine we are substituting x as tan theta. So your LHS is going to become 2 times tan inverse of x के बदले हमने पुट किया है tan theta. So are we getting 2 tan inverse of tan theta? And just now we have seen that tan inverse of tan x is what? X. तो इफ यू पुट x इज इक्वल टू tan थीटा, तो LHS का आंसर मुझे बताओ क्या आ रहा है, 2 tan इनवर्स ऑफ tan थीटा विच इज यू कैन से 2 थीटा। कमिंग टू द RHS, अगर आपने tan थीटा पुट किया है तो RHS इज गोइंग टू बिकम साइन इनवर्स ऑफ 2 tan theta upon 1 plus tan square theta. Now students, in your 11th standard you have studied this formula. 2 tan theta upon 1 plus tan square theta is sin 2 theta. So are we going to get sin inverse of sin 2 theta, which is same as you can say 2 theta according to this formula. Sin inverse of sin x is x. So we are getting LHS is 2 theta, RHS is 2 theta. Understood students? Likewise you can similarly prove तो सेकेंड एंड द थर्ड वन, यहाँ पे हमको वापस x को tan थीटा पुट करना है, तो LHS रिमेन्स 2 थीटा फॉर ऑल द 3 प्रॉपर्टीज। RHS में यहाँ पे क्या आ जाएगा, इमेजिन करो cos इनवर्स ऑफ 1 माइनस tan स्क्वायर थीटा अपॉन 1 प्लस tan स्क्वायर थीटा विच इज यू कैन से cos 2 थीटा, एंड अगेन cos इनवर्स ऑफ cos 2 थीटा बिकम्स 2 थीटा। लाइकवाइज इफ यू पुट tan थीटा ओवर हियर, तो ये ब्रैकेट कन्वर्ट हो जाएगा tan 2 थीटा में, एंड tan इनवर्स ऑफ tan 2 थीटा इज 2 थीटा। ओके स्टूडेंट, लेट्स मूव टू द नेक्स्ट कॉन्सेप्ट. Okay students, so coming to the next concept which is known as standard substitution table. Now students, as we can see in this table we have two columns, one is for expression and one is for substitution of x. So जब भी आपको क्वेश्चन में ऐसे एक्सप्रेशन दिखेंगे तो you are going to go for substitution. The reason behind this table is कि if you put the value of x as the mentioned terms, the given expression would be simplified and hence the given sum. Students, this table is very important because it will not only appear in inverse trigonometric function, it will appear in continuity and differentiability as well as sums of integration. Okay, so please understand this table nicely. Now supposing if you have a term root of 1 minus x square, तो हम लोग पुट करेंगे sin थीटा और cos थीटा. The reason is I'll just show you with the help of an example. Suppose if we have a sum sin inverse of root 1 minus x square, and you know the substitution that we are going to put sin theta or cos theta in place of x. तो अगर हमने चूज किया cos theta, so हमको आ जाएगा यहाँ पे sin inverse of root of 1 minus cos square theta. Okay, so we get sin inverse of root of what is 1 minus cos square theta, sin square theta. तो यहाँ पे हमको आ जाएगा sin square theta. What is root of sin square theta? Sin theta. So we are left with sin inverse of sin theta, which we very well know according to the property number 1, it is theta. So students, have you seen how we have simplified the given expression as well as the sum got simplified? तो बाहर हमेशा एक्सप्रेशन के साथ एक इनवर्स ट्रिग्नोमेट्रिक फंक्शन बैठा होगा जो कि आपके सब्स्टिट्यूशन की मदद से सम को सिंप्लीफाई कर देगा. ओके स्टूडेंट, सो दैट इज द बेसिक आइडियोलॉजी बिहाइंड स्टैंडर्ड सब्स्टिट्यूशन टेबल. नाउ आई जस्ट एक्सप्लेन द अदर सब्स्टिट्यूशंस. सपोज यू हैव रूट ऑफ a स्क्वायर माइनस x स्क्वायर, तो ये इसके जैसा ही है, सिर्फ यहाँ पे 1 के बदले आपको a पुट करना है. ओके, सो यू आर गोइंग टू से a sin थीटा और a cos थीटा. आइडियोलॉजी रिमेन्स सेम. Now if you have root of 1 plus x square, तो why we are putting tan theta और cot theta? Because root of 1 plus tan square theta क्या होता है? 1 plus tan square theta is sec square theta. So we are going to come get a sec term outside the square root. So basic ideology क्या है कि ये जो square root term है, the root जो है उसको हमको निकालना है. We want to get rid of the square root term. Okay, that is the basic ideology. So if we have root of a square plus x square, so you can go for a tan theta or a cot theta. If you have root of x square minus 1, तो if you put sec theta, तो रूट में हमको मिलेगा sec square theta minus 1, which is root of tan square theta, and we get tan theta. So students, अभी आपको समझ में आ रहा है कि why we are doing the following substitution. Coming to the sixth one, if you have root of x square minus a square, यहाँ पे 1 था, यहाँ पे a square है, तो हम लोग a sec theta और a cosec theta पुट कर देंगे. Now students, अभी आप बोलेंगे कि सर इसमें से कौन सा चूज करना है, sin theta चूज करना है कि cos theta चूज करना है? वो आपको जो बाहर इनवर्स फंक्शन बैठा होगा उसको देख के आपको सब्स्टिट्यूट करना है. ओके, एज इन व्हेन वी मूव अहेड, जैसे आपको प्रैक्टिस मिलेगा ऐसे आपको स्ट्राइक होते जाएगा कि वेदर यू हैव टू चूज sin थीटा और cos थीटा. ओके, कमिंग टू द सेवेंथ वन, इफ यू हैव 3x minus 4x क्यूब, तो वी आर गोइंग टू पुट sin थीटा बिकॉज 3 sin थीटा minus 4 sin क्यूब थीटा इज द फॉर्मूला फॉर sin 3 थीटा. Okay, coming to the eighth one, 4x cube minus 3x, we put cos theta because this will become 4 cos cube theta minus 3 cos theta, which is cos 3 theta. If you have a big term like this, 3x minus x cube upon 1 minus 3x square, you go for tan theta because if you put tan theta, this will convert to tan 3 theta का formula. Okay, if you have 2x root 1 minus x square, so we have just now seen root 1 minus x square रहेगा तो we go for sin theta और cos theta. रूट ऑफ 1 प्लस एक्स रहेगा तो वी आर गोइंग टू गो फॉर cos 2 थीटा और cos थीटा. उससे फायदा ये होगा कि रूट ऑफ 1 प्लस cos 2 थीटा अगर पुट किया है So what is the formula for 1 plus cos 2 theta students? It is 2 cos square theta. तो हमको आ जाएगा 2 cos square theta. So which will give you root 2 cos theta. So we are getting rid of the square root term. Likewise, if you have 1 minus x, so again we go for cos 2 theta because 1 minus cos 2 theta का formula क्या है students? It is 2 sin square theta. So again we got rid of the square root term. So है जैसे जैसे आगे बढ़ेंगे स्टूडेंट्स तो वैसे आपको ये ज़्यादा क्लियर होते जाएगा. Students, before moving to exercise 2.2, kindly understand the properties of inverse trigonometric function nicely and try to memorize them. Also be clear with the standard substitution table so that exercise 2.2 is going to become very easy for you. Okay, so let's move ahead. So students, before we begin exercise 2.2, I would like to mention one point. Okay, in case you don't remember the 11th standard trigonometric formula, I suggest please memorize those formulas and then begin with the exercise because they are going to prove very useful for the remaining part of the chapter. अभी से जो चैप्टर है वो फुल फार्मूला बेस्ड चैप्टर है, तो अगर आपको फार्मूला पे ग्रिप है तो सम्स बहुत ही इजी होने वाले हैं. ओके, सो लेट्स स्टार्ट विद द फर्स्ट क्वेश्चन. यू वांट टू प्रूव दैट 3 sin inverse of x is sin inverse of 3x minus 4x cube. So as we have just now seen in the standard substitution table 2 minutes back, वहाँ पे आपको ऐसा एक्सप्रेशन दिखा था 3x minus 4x cube. So we very well know we have to put x is equal to sin theta. So let us start with the RHS and we are going to say let x is equal to sin theta. Therefore we can say that theta is equal to sin inverse of x. So now your RHS is going to become sin inverse of 3 sin theta minus 4 sin cube theta. Students, according to the trigonometric formula, this full expression is sin 3 theta. Okay, so what we are going to get here is sin inverse of sin 3 theta. And students, if you remember property number 1, we have seen that sin inverse of sin x is x. Okay, so we are going to get here 3 theta. But what is your theta students? It is sin inverse of x. So we get 3 sin inverse of x, which is your LHS. Simple students. Okay, let's move to the second one. ये भी सेम टाइप ऑफ क्वेश्चन है, ओनली कॉस इज इनवर्स इज इन्वॉल्व्ड. सो अगेन आपको याद आ रहा होगा एक्सप्रेशन इन द स्टैंडर्ड सब्स्टिट्यूशन टेबल we had seen 4x cube minus 3x. So we are going to substitute cos theta in the RHS. Okay, so same procedure we have to follow. We are going to say let x is equal to cos theta. So therefore we can say theta is equal to cos inverse of x. So we begin with the RHS. Okay, so it is now going to become cos inverse of क्या आएगा बोलो यहाँ पे 4 cos cube theta minus 3 cos theta. Students, this again turns out to be the formula for cos 3 theta. Okay, so we are going to get cos inverse of cos 3 theta, which is you can say according to the property cos inverse of cos x is what? X. Okay, so what we are going to get here? 3 theta. But what is theta? We have substituted cos inverse of x. So we are going to get 3 cos inverse of x, which you can say it is your LHS. Okay students, let's move to question number 3. Okay students, so in the question number 3, he wants us to prove that tan inverse of 2 upon 11 plus tan inverse of 7 upon 24 is equal to tan inverse of 1 upon 2. So let's begin with LHS. So we can say LHS is equal to tan inverse of 2 upon 11 plus tan inverse of 7 upon 24. Now students, is it resembling tan inverse of x plus tan inverse of y? So the formula for it we very well know. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy. Okay, so we are going to apply this formula. So consider this term as your x and this is your y. So what do we get is tan inverse of x के बदले लिखेंगे 2 upon 11, y के बदले लिखेंगे 7 upon 24 upon 1 minus 2 upon 11 into 7 upon 24. So if you simplify, we do cross multiplication over here. So you get tan inverse of यहाँ पे आ जाएगा 48 plus 77 upon 24 into 11 becomes 264 upon, if you multiply here, so यहाँ पे multiply हो जाएगा 264 minus 14 the whole upon 264. Okay, so now 264 get cancelled, so we are left with tan inverse of यहाँ पे बोलो क्या आएगा 77 plus 48 will give you 5 and your 125 upon denominator is 264 minus 14 which is 250. So if you simplify you get tan inverse of 1 upon 2 which is your RHS. Okay students, let's move to the next one. Okay, in the fourth question he wants us to prove that 2 tan inverse of half plus tan inverse of 1 upon 7 is tan inverse of 31 upon 70. Now students, there are two ways to solve this. One is by property and one is by normal method. तो देखते हैं, इफ यू सॉल्व बाय प्रॉपर्टी यू स्टार्ट विथ LHS, सो 2 tan inverse of half plus tan inverse of 1 upon 7. Now students, if you remember the property, 2 tan inverse of x is same as tan inverse of 2x upon 1 minus x square. Okay, तो ये प्रॉपर्टी हम लोग अप्लाई कर सकते हैं ये टर्म में. और द अदर मेथड इज, since there is 2 over here, so you can split this in two parts, tan inverse half plus tan inverse half, then apply the formula for tan inverse x plus tan inverse y. उन दोनों को सिंप्लीफाई करो, फिर उसका जो रिजल्ट आएगा वो इसके साथ सिंप्लीफाई करो. ओके, सो आई एम डूइंग बाय प्रॉपर्टी मेथड. सो आई एम अप्लाइंग दिस फॉर्मूला इन द फर्स्ट टर्म. सो व्हाट आई एम गोइंग टू गेट हियर इज, बोलो क्या आ जाएगा इधर, इसके बदले वी आर गोइंग टू राइट tan इनवर्स ऑफ 2 into x. So 2 into x is 1 upon 2 upon 1 minus 1 upon 2 the whole square. So if you simplify, we are going to get 2 and 2 gets cancelled, plus ये term जो है tan inverse of 1 upon 7 as it is. So we get tan inverse of 1 upon 1 minus 1 upon 4 plus tan inverse of 1 upon 7. So if you take LCM over here, we are going to get tan inverse of, यहाँ पे हमको आ जाएगा 1 upon 4 minus 1 is going to become 3 upon 4 plus tan inverse of, we get 1 upon 7 as it is. Okay, so if you simplify this, you get tan inverse of 4 upon 3 plus tan inverse of 1 upon 7. Now again we apply the formula for tan inverse x plus tan inverse y. So what do we get is tan inverse of, क्या था formula, x plus y upon 1 minus x into y. Okay students, so if you further simplify, we get tan inverse of, क्रॉस मल्टीप्लिकेशन परफॉर्म करो, तो यहाँ पे we get 28 plus 3 upon this becomes 21 upon, ये प्रोडक्ट है 21, it goes over here, so we get 21 minus 4 upon 21. So what do we observe is 21 gets cancelled, so you get tan inverse of 31 upon 17, which is you can say your RHS. Okay students, let's move to the next one. Okay students, so in the question number 5, he is asking us write the following in the simplest form. Means you want to simplify this given expression. So now comes the use of standard substitution table. Students, please refer the table and tell me what we have to substitute over here in place of root of 1 plus x square. वहाँ पे हम लोग x का वैल्यू क्या पुट करते थे? We are putting x is equal to tan theta. Okay, so let us see what do we get. So if you put x is equal to tan theta, so therefore we can say that theta is equal to tan inverse of x. Okay, so now your expression becomes tan inverse of, जहाँ पे भी x है वहाँ पे आपको tan theta पुट करना है, so you get square root of 1 plus tan square theta minus 1 upon tan theta. So we get tan inverse of, students, what is 1 plus tan square theta? It is sec square theta, so we get square root of sec square theta minus 1 upon tan theta. Now square root के बाद जो sec theta टर्म निकलेगा, okay, so we are going to get tan inverse of sec theta minus 1 upon tan theta. To further simplify, we can substitute sec theta is 1 upon cos theta and tan theta is sin theta upon cos theta. So let us see what do we get. So we are going to say tan inverse of, हमको आ जाएगा यहाँ पे 1 upon cos theta minus 1 upon tan theta के बदले we are writing sin theta upon cos theta. So if you simplify further, we get tan inverse of, take LCM over here, so you get 1 minus cos theta upon cos theta upon, नीचे आ जाएगा sin theta upon cos theta. So students, if you observe, यहाँ पे क्या कैंसिल हो रहा है, cos theta and cos theta gets cancelled, so we are left with tan inverse of 1 minus cos theta upon sin theta. Now students, if you remember the trigonometric formula for 1 minus cos theta and trigonometric formula for sin theta, I just show you here. 1 minus cos x का क्या formula है, 2 sin square x upon 2, and sin x का क्या formula है students, it is 2 sin x by 2 into cos x by 2. Okay, which you have learnt in your 11th standard. So we make use of that. So you get tan inverse of, देखो यहाँ पे क्या आ जाएगा, 2 sin square theta upon 2 upon sin x के बदले क्या पुट करेंगे, sin theta के बदले 2 sin theta by 2 cos theta by 2. 2 gets cancelled, one sin term gets cancelled, so you are left with sin theta by 2 upon cos theta by 2. So we can say which is tan inverse of tan theta by 2. And you remember the property, tan inverse of tan x is what students, x. So tan inverse of tan theta by 2 is going to be your theta by 2. So if you resubstitute the value of theta, which is you can say tan inverse x, so your answer is tan inverse of x upon 2. Okay students, let's move to the next one. Okay students, in the question number 6, he is telling us to simplify this expression tan inverse of 1 upon root x square minus 1. Again students, please observe the standard substitution table. There you will find this term root of x square minus 1. वहाँ पे हमने लिखा है put x is equal to sec theta or cosec theta. So let us go for putting x is equal to cosec theta. So we can say put x is equal to cosec theta. So therefore we can say theta का value क्या हो जाएगा यहाँ से, cosec will come over here. So you get cosec inverse of x. So now you get tan inverse of, you get 1 upon root of x के बदले we are putting cosec theta, so you get cosec square theta minus 1. Students, what is cosec square theta minus 1? It is cot square theta. So we are going to get tan inverse of 1 upon root of cot square theta. Okay, so what is the next step? Tan inverse of 1 upon बाहर निकलेगा cot theta and 1 upon cot theta is tan theta. So we can say tan inverse of tan theta, which is by the property theta. But what is theta we had substituted? Cosec inverse of x. So that's your answer. Okay students, what if you had put x is equal to sec theta? I'll just show you. You are going to get your sec square theta minus 1. तो यहाँ पे मिलेगा tan square theta. Okay, so बाहर निकलेगा tan theta. So we are going to get 1 upon tan theta. So you would read this step students. You are going to get tan inverse of cot theta. Okay, now यहाँ पे tan inverse है, तो it is very necessary that you want to convert this cot function to tan function. तो we make use of allied angle concept. तो cot को हम लोग क्या लिखेंगे? Tan of 90 minus theta. So we are going to get tan inverse of tan theta, which is theta. So हमारे पास बचेगा pi by 2 minus theta. But you had substituted what? X is equal to, क्या पुट किया था हम लोग ने? sec theta. So theta का वैल्यू वहाँ पे क्या मिलता था हमको? sec inverse of x. Okay. So your answer would be pi by 2 minus sec inverse of x. And if you remember, sec inverse x plus cosec inverse x is equal to what? Pi by 2. So we can say that pi by 2 minus sec inverse x is same as cosec inverse x. तो आंसर हमको दोनों तरह से आता है. But if you had put x is equal to sec theta, so you can see just 2-3 steps become more. That's only the reason. Nothing much difference. Okay. So let's move to the next sum. Okay students, now in the 7th question, he wants you to simplify tan inverse of root of 1 minus cos x upon 1 plus cos x. Now students, बाहर tan inverse बैठा है, तो कैसे भी करके हमको ये ब्रैकेट में tan function लाना है, so that in the last step we can apply the formula tan inverse of tan x is x. Okay, so we very well know the trigonometric formula for 1 minus cos theta. क्या होता है students? It is 2 sin square theta by 2, and the formula for 1 plus cos theta is 2 cos square theta by 2. So if we make use of this formula in the question, we are going to get tan inverse of root of 1 minus cos x के बदले क्या लिखेंगे students? We are going to write 2 sin square x upon 2, and in the denominator we are going to get 2 cos square x upon 2. Now what will happen? 2 gets 2. So sin square upon cos square becomes tan square. So you are left with tan inverse of square root में बचेगा tan square x upon 2. So root के बाहर क्या आएगा? Tan function. So you get tan inverse of tan of x upon 2. So it is like, you know, tan inverse of tan x, which is x. तो x के बदले क्या दिख रहा है? X by 2. So your answer is x by 2. Okay students, so in the question number 8, again you want to simplify this expression. Now observe the bracket carefully, and you want to convert this full bracket to a tan function. Okay, we want to get a term in terms of tan function. So कैसे करेंगे? Okay, so see the basic step. What we are going to do here is taking cos x common in numerator and denominator. Just wait for one step and see why we are doing this. So we get tan inverse of, if you are taking cos x common in numerator and denominator, तो ऊपर cos x common निकलेगा और यहाँ पे हमको मिलेगा 1. And since there is no cos x term over here, so we get 1 minus sin x upon cos x. Likewise in the denominator, we are taking cos x common. So I am going to get cos x bracket, यहाँ पे मिलेगा 1 plus sin x upon cos x हो जाएगा. Okay, so now cos x and cos x gets cancelled, so we are left with tan inverse of, is it like 1 minus tan x upon 1 plus tan x. Now students, in your bachpan, matlab in your 11th standard, we have studied one formula. If you remember, tan of pi by 4 minus x का formula है, देखो 1 minus tan x upon 1 plus tan x. So that is why students, at the starting of the lecture I told you कि 11th standard के trigonometric formula बहुत ही important है. Okay, so what we are going to get here is tan inverse of, because of this formula, this full expression is going to reduce to tan of pi by 4 minus x. Okay, so it is like, you know, tan inverse of tan x. So this full term is x. So your answer is pi by 4 minus x. Okay students, let's move to the next one. So again students, this is the sum based on standard substitution table. Since there is tan inverse term waiting outside, we have to convert the full bracket to a term in terms of tan function. तो हम लोग क्या करेंगे, ऑब्जर्व द सब्स्टिट्यूशन टेबल. आई हैव ऑलरेडी गिवन यू द एक्सप्रेशन रूट ऑफ ए स्क्वायर माइनस एक्स स्क्वायर के बदले हमको पुट करना है x इज इक्वल टू ए साइन थीटा और a cos थीटा. लेट्स गो फॉर a साइन थीटा. सो वी आर गोइंग टू से पुट x इज इक्वल टू a साइन थीटा. देयरफॉर वी कैन से दैट साइन थीटा इज इक्वल टू क्या हो जाएगा इधर x अपॉन a. So therefore we can get the value of theta from here, which is you can say sin inverse of x upon a. Now let's come back to the expression. So it is going to become tan inverse of, जिधर भी x है उधर हम लोग को पुट करना है a sin theta. So I get here a sin theta upon square root of a square as it is, और x के बदले we are putting a sin theta, तो ये टर्म हो जाएगा a square sin square theta. Okay, so if you further simplify, you get tan inverse of a sin theta upon, इन दोनों टर्म में से क्या कॉमन है, a square is common, so I am going to get here 1 minus sin square theta. So what will happen in the next step? So we get tan inverse of numerator is a sin theta upon denominator में से students we are going to get square root of a square cos square theta, and both are perfect squares, so square root के बाहर आ जाएंगे. So we are going to get tan inverse of a sin theta upon, बाहर निकलता है a cos theta, a and a gets cancelled, and you know this is tan inverse of tan theta, which is like tan inverse of tan x, which is x. But what is your theta students? It is sin inverse of x upon a. Okay students, in the 10th question the same concept applies. Since there is tan inverse term waiting outside, we have to convert the full term in terms of tan function. So let us see how to convert. If you remember in the standard substitution table, there was one expression 3x minus x cube upon 1 minus 3x square. Okay, so we had to put there x is equal to tan theta. उससे फायदा क्या होगा, 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta would reduce to tan 3 theta. लेकिन if you compare this expression, they are a bit different. So what is the basic requirement that if you want to convert this expression in the form of this one, तो हमको यहाँ पे basic requirement क्या है, 1 चाहिए हमको. Okay, so in order to make this term 1, so what we do is we can simply say taking a cube common in numerator and denominator. तो उससे देखो अभी फायदा क्या होने वाला है, we are going to get tan inverse of, यहाँ पे हमको if you are taking a cube common, so there was a square over here, so what will happen is you are going to get x upon a, and यहाँ पे a cube का term था ही नहीं, तो it is going to become x cube upon a cube. Likewise in the denominator if you are taking a cube common, so हमको मिल जाएगा यहाँ पे 1 minus 3. Since there is only a term over here and you have taken a cube common, so we are going to get here 3x square upon a square. Okay, now what will happen is a cube and a cube gets cancelled. So now if you simplify, you are going to get tan inverse of 3x upon a minus x upon a the whole cube upon 1 minus 3 into x upon a the whole square. तो आपको स्ट्राइक हो रहा है, मैंने क्या किया है, आई हैव रिटन इन द फॉर्म 3x minus x cube upon 1 minus 3x square. तो इन द एक्सप्रेशन आई हैव गिवन इन टर्म्स ऑफ x, तो यहाँ पे x के बदले x अपॉन है, सो देयर वी हैड पुट x इज इक्वल टू tan थीटा. तो यहाँ पे हम लोग क्या पुट करेंगे, पुट x अपॉन a इज इक्वल टू tan थीटा. ओके स्टूडेंट, बिकॉज वी हैव 3x अपॉन a नॉट 3x, सो देयरफॉर वी कैन से दैट फ्रॉम हियर थीटा इज इक्वल टू tan inverse of x upon a. So now if you go back to the question, we are going to get tan inverse of, ब्रैकेट में हमको मिलेगा 3 tan थीटा minus tan cube theta upon 1 minus 3 tan square theta. Okay, so this full formula is for tan inverse of, ये होता है tan 3 theta का formula, ये पूरा ब्रैकेट का formula होता है tan 3 theta. So if you, it is like tan inverse of tan x which gives you x, लेकिन x के बदले क्या है 3 theta. But again what is your theta over here, it is tan inverse of x upon a. Okay, so that's your simplified answer. Okay students, I hope you have understood properties of inverse trigonometric function, standard substitution table and question numbers 1 to 10 of exercise 2.2. In the next lecture, we continue from question number 11 onwards. Please like, share and subscribe my channel. Take care and goodbye.